So today we'll discuss about antibiotic production. So, one of the most widely used biomolecule, and it is also considered as blessings of this bioprocess engineering. And if you go back to the history, then you'll be able to see the first antibiotic discovered by Alexander Fleming is penicillin, and that happened in 1929. But chemical production or mass production of antibiotic actually happened during World War II. And sometimes people actually thank this massive war because of this war only we got large scale production of antibiotics, because scientists also got motivated to produce this antibiotic, because during this war many soldiers are dying because of simple injuries. So you can say during that period when they could produce at a very large scale, then they could save many soldiers' lives. So many times we actually uh, say that it is really, we are really thankful to that big massive war, because of the World War II we got antibiotics. And when you talk about antibiotic production by organism, it is actually a error in their metabolism. They don't want to produce antibiotic unless they have some inborn error in their metabolism. So you can say this production of antibiotic by this microorganism is not a desired product produced by the particular organism. It is, it get produced because of some mutation within their uh, system, and in their metabolic pathway they produce a certain amount of compounds which are actually known as secondary metabolites. So if you can remember the growth non-growth associated product formation, there you will get organism which will just require certain amount of substrate for their growth, and after achieving certain amount of growth they will start producing some secondary metabolites whenever they will get deprived from certain nutrients. Suppose an organism requires certain amount of carbon and nitrogen, so they will start growing by utilizing carbon and nitrogen present in the media, and after a certain period of time whenever you have depletion of carbon or depletion of nitrogen in the media, then they will start producing some other, because the metabolic pathway will trigger and then start producing something else, and this secondary metabolites, this antibiotic is actually one kind of secondary metabolites. So it is mostly an product formation due to non-growth associated product formation process. And when you talk about antibiotic production, two three major challenges are also there. One is getting appropriate strain which will allow you to get reasonable amount of antibiotics. Second thing is also the titer, means the concentration of antibiotic you get in the media. So first thing is to get appropriate strain which will produce sufficient amount of antibiotic or certain antibiotic compounds in repetitive manner. Like if you get an organism which can produce antibiotic for 10 generation, and after 11 generation it deviates and it produces something else, then it will actually not be very helpful when you try to translate that process to an industrial scale level. So you need to get a consistent performer, like organism which will consistently give similar kind of antibiotic. And also you have to make sure the organism should not give any other impurities, because in antibiotic production process, impurities or production of yellow pigment or other impurities is also a major concerning factor. So if you get organism which can produce substantial amount of antibiotic, but it will also produce some other secondary metabolite which is considered as contaminant, then you will have subsequent downstream, means difficulties in downstream operation to remove them. So you need to get a consistent performer. You need to get organism which can produce substantial amount of antibiotic, So the concentration of antibiotic in the media is also important. Then the third factor is impurities. So an organism should not produce any other impurities while producing antibiotic. Because if you have production of other impurities, you will have problem with downstream operation. So easy separation or easy purification step is important. Otherwise, the process will not be economically feasible. Sometimes we use very complex substrate which will essentially promote the production of one kind of antibiotic. But it is very much possible that separation of the finally produced antibiotic from that broth could be a Herculean task, means could be very, very difficult task. So whenever you need to go for this process development for antibiotic production, you need to make sure that you get good producer or the organism should consistently produce similar kind of antibiotic. Titer should be reasonably good. That means concentration of antibiotic you get in the media should be reasonably good. And also it should not produce any more impurities. And fourth is separation or downstream operation should not be very critical or difficult to get rid of residual substrate or residual component present in the broth. So initially, when they start producing this antibiotic in the laboratory condition, they realize the organism which are responsible for antibiotic productions are actually having means showing variation in production capacity. So they realize that whenever you create multiple mutation in the same organism, you may get increase in production capacity or increase in concentration of antibiotic produced by one particular organism. So initially when they started this process, they realized the titer of native organism or the production capacity of native organism is very, very small. So at the initial period, they didn't get much success because the concentration they're getting is less than 1%. So if you get very low concentration in the broth, subsequently you need to have really very massive downstream operation process. And if you get very complex downstream operation process or expensive downstream operation process, automatically cost of the product will also increase. So initial period, like immediately after discovery of antibiotic, when they tried to produce it in larger scale. As I mentioned, in 1929, they dismissed Alexander Fleming discovered the penicillin, and then they started producing that in industry scale or larger scale within 3-4 years, but they didn't get good success because commercially the process was not very viable. Reason is low titer because they're getting almost 0.1% of amount whatever we get in today's world. Means when you talk about antibiotic production process in current system, that is actually almost 10 to 20 times higher than the earlier cases. Now, actual production or larger production process actually happened in during Second World War, and they could actually get almost 10,000 fold increase, 1,000-fold increase of penicillin production in the final product form. So the subsequent increase actually happened due to use of genetically modified strain, or you can say mutated strain. It is you are not deliberately doing any genetical modification. You are just exposing this organism to different mutation causing agent like X-ray or UV radiation, and then you are trying to grow them to see whether you are getting any improvement in their production capacity. And it was observed the raw native strain, when it got exposed to different other mutagenic agent, it could actually give substantial increase in production. So in normal scenario, when you talk about this simple penicillium notatum or the fungi responsible for production of penicillin, they can produce it can produce say 1 milligram per ml, whereas after doing a little bit of mutation, you could actually get 20 times higher production capacity, like 20 milligram per ml of antibiotic. So to increase the yield, they started using different mutagenic agents. Only problem is whenever you develop any mutated strain, stability of that strain will be a questionable factor. So I mentioned that you need to get a consistent performer. That means even if you use a mutated strain, that strain should show similar kind of performance generation after generation. So if you get a stable organism which is also producing good amount of antibiotic, then only you can use the strain for industrial production of antibiotic. So currently, two different organisms are used for production of penicillin. So when you talk about penicillin production, you actually get two different organisms. One is Penicillium notatum, that was first explored by the means inventor, means Alexander Fleming actually used or discovered penicillin from Penicillium notatum. But most of the current process we use Penicillium chrysogenium. Penicillium chrysogenium, that's the most widely used organism for production of penicillin. And Penicillium notatum is not uh, used widely because the titer is less. And whenever you try to produce higher concentration of penicillin, then you actually go for organism which can give you higher yield, and that's why you prefer Penicillium chrysogenium. And also in penicillin production, different kind of substrates are used as per requirement. Like if you have a specific precursor, means when you use a specific substrate, you will get a specific type of penicillin, because different types of penicillins are also available in the market. So when we talk about penicillin production, we are not talking about only one particular compound. So if I just show you the structure of penicillin, then actually you'll get a better idea. So when you talk about the penicillin molecule, you will get this structure where you can have replacement of R by different other groups to get different varieties of penicillin. So penicillin O, penicillin V, penicillin G, penicillin F, different kind of penicillin you can get by just changing this R group. So most common penicillin is penicillin G. So just replace this R by this aromatic ring. So if you replace this R by this aromatic ring, then you will get penicillin G. Yes, most commonly used antibiotic or penicillin. In some cases, we also use penicillin F. So for penicillin F, this R group will have little bit um, straight chain instead of aromatic ring. You will actually have a straight chain. So for penicillin F, this R group will be replaced by this straight chain, whereas for penicillin G, you will have this aromatic ring. So we can see when you try to produce this penicillin, if you use different kind of substrate to actually provide this R, then you will end up by getting different kind of. Just a second. Can you see the full screen?
Yes, sir, we can.
Okay. So when you replace the R group, you will get different kind of penicillin. And to replace this R group, we actually provide different kind of additives in the substrate. So these additives are also known as precursor because you are trying to add certain things which will ultimately help you to get the desired penicillin. And when you try to produce penicillin, I have mentioned about 4 different criteria to select the organism when you talk about industrial production of penicillin or antibiotic, say not only penicillin and any other antibiotic. Similarly, for production of penicillin, you need to make sure this 3 different conditions are met. So one is acid stability. That means the penicillin, whatever you will produce, it should be stable. Then you can, if it is not stable in the acidic condition, then you will not be able to take it and as oral medicine. So you always try to consider easy administrative drug because if you can take the drug orally, then it will actually go through the digestive tract. So whatever acid, mineral acid we have in our digestive system, that particular chemical should withstand that acidic condition. So then, if advantage is if you have acid stability, then you can use it as oral medicine. So that is one point. Second point is the penicillin, whatever you will get, that should have very low allergenicity because many times different antibiotics, not only antibiotics, different other drugs also allergenicity. So different antibiotic and other drugs can actually show different kind of allergy to the user. So you have to make sure the kind of antibiotic you produce, that should not show any allergy to the user. So lower allergenicity is also uh, important, and sometimes certain population will show allergy, some other population will not show allergy, because human body in different regions also show different kind of allergic response to different chemicals. So it is very possible that majority of the population will show low allergy, maybe a smaller population will show allergy. So for those population, you need to use a different kind of antibiotic. Like we know, uh, penicillin G, penicillin G can show allergic response to a minute population, like less than 10% or 10% population, whereas for them penicillin O or penicillin F can work better. So lower allergenicity is also another important parameter. And third parameter is the resistance to penicillin inactivating enzyme. So the inherently this particular medicine resistance to penicillin inactivating enzymes. So these three factors should be considered when you talk about production of this penicillin. So penicillin G, those who are allergic to penicillin G, they generally go for penicillin O or F, and acid stability is required, then you can use it as a oral medicine. And obviously, if you have this compound, the kind of penicillin, suppose penicillin G is less uh, susceptible to resistance, then you can actually use, you can get better treatment. If one particular penicillin is more prone to uh, inactivation due to presence of different enzyme, then you may not use it for treating a specific disease. And many penicillins, like this R group, you are actually talking about replacement of R group to get different kind of penicillin. So many penicillin can be produced biosynthetically, and some penicillin would require chemical synthesis. So if you can chemically synthesize, that is also possible. So one option is to first to produce one parent molecule and then produce different derivatives by using different chemical methods. So it will be a combination of chemical and biosynthetic uh, system. Whereas if you get only um, biosynthetically produced chemical, penicillin, then after fermentation, the final product, whatever you will get, like penicillin G, if you're getting as a final product, then you just follow different purification step to get the concentrated penicillin G at the final product. So biosynthesis, physicochemical plus biosynthesis are also known as semi biosynthesis or semi synthesis. And third category is chemical synthesis. But every time, whenever whatever process we follow, you have to make sure the final product is impurity free, and it should not show allergy. It should be acid stable, and it should show very low inactivity towards different enzymes. So most of the cases, when you talk about penicillin production, people try to use a stable culture. It is very much possible that one particular culture is developed after multiple mutation, and they found that the stability of the culture is significantly good. Then they just use that culture, and many industry, they have their own culture and they don't disclose it to others, because obviously in the market they may have other competitors. So in their culture development system, whatever culture they develop, they just keep it for their own production. But for developing culture, the process is similar. You do mm, mutation, deliberate mutation, and then that means you actually expose them to either X-ray or UV radiation, and then you actually do some screening. So after each mutation cycle, you just do screening and then see what particular fungi is giving you higher titer or higher yield, and then to maintain the stability, you do very infrequent transfer, because if you frequently transfer them, you are actually essentially having more chance to lose the mutation within the strain. And most of the time, whenever they try to store the strain, either they lyophilize it or they just prepare some slant or just suspended them in a media and then store it in the liquid nitrogen. So mostly when you compare the different preservation techniques, you will find the sample prepared in agar's land will have more chance to show instability, because they will grow in multiple numbers, and it is very much possible that in a given generation they will lose the specific genetic sequence whatever they obtain through the mutation, and it will essentially reduce the production ability of penicillin or any other antibiotic. So fermentation media is also quite important because, as I mentioned, the precursor, whatever you add to the fermentation media, that will help you to get the final product. So fermentation media also has significant impact. So people have already tried with different complex media, and also they tried with different chemically defined media, because in a industry scale, it is always preferred to use defined media, because then you can actually do your optimization and you can get good reproducibility by using defined media. So people have tried with different other by adding different other organic substances like yeast extract, meat product, or casein digest. So all these targets are actually to get higher titer of antibiotic or higher yield of antibiotic. And it was found that when lactose was used as carbon source, although lactose is quite expensive, generally the lactose or the organism present in the system, they prefer lactose over any other carbon sources, and you get little bit higher titer. So people also tried to replace lactose by sucrose and glucose in chemically defined media without compromising the titer. So in another uh, way of reducing the cost of operation is to use some byproduct obtained from other industry as the carbon source. Like in earlier cases, we have shown if you use molasses to produce um, ethanol, then actually you get little bit of benefit. Similarly, here also people try to use molasses to produce antibiotic, but only problem was molasses is not a defined carbon source. You get different other component or many other chemicals present in molasses. So at the end of the process, when you try to separate or purify the antibiotic, you end up by getting a lot of other undesired product, and which could be very difficult to separate from the antibiotic broth. So in such cases, even if you get really very low cost for growing the organism, or the production process would require significantly less amount of money due to use of this cheap raw material, but downstream operation could be very expensive. And when you try to do the uh, economic balance, considering all the processes like fermentation and downstream operation, then it is very much possible that you may not find that process is economically feasible, because raw material could be very cheap, but downstream operation could be very expensive, and that will make the entire process redundant. So people have tried to use this cheap raw material like molasses, but they didn't get good success because the downstream operation was very expensive. And this penicillium chrysogenium, which is one of the most important strain used for uh, penicillin production, they means people have means research have shown that if you use corn strip liquor you can get from beer industry. So if you get corn strip liquor, then actually you get little bit of advantage. That has two different reasons because corn strip liquor has sufficient amount of um, glucose and lactose also, and it also has certain precursors which will help you to produce penicillin G, like phenyl, if phenethylamine, or I can just write down the precursor because this precursor actually present in constant liquor, and if it is not there, then actually you have to add a substitute compound to the refined media. Like you have option to use corn strip liquor, or you have option to use another synthetic media or defined media. So here, by default, you are getting lactose, which is a preferred substrate for this organism to produce penicillin, say 3 to 4%. You also get glucose, around 0.5%. Then you can get some acetic acid, you can get lactic acid, and most importantly, you get the benzene ring supplier or precursor. You also get different amino acids and reasonable amount of ammonia. Whereas defined media will actually need to mimic the situation, so you have to add lactose, you have to add certain amount of glucose, you have to add acetic acid or lactic acid. Only thing is for this, typically they use, so most of the component will be very similar. So when you talk about the precursor addition for getting this phenyl group, here they generally we add phenyl acetic acid. And to add this ammonia, you can use ammonium sulfate. So corn strip liquor is one of the preferable media because you are getting this good carbon sources and also you are getting a precursor for producing penicillin G. And when you try to grow them, you need to provide sufficient amount of aeration because this entire process will be aerobic fermentation. So you need to provide sufficient amount of aeration and agitation. And it is observed that this fungi strain, they prefer to have the surface fermentation than the submerged fermentation. So when you try to grow the fungi in a reactor, you have option to disperse them in the liquid. So you just keep them submerged in the liquid. Another option is you get this uh, a mat of fungi grown on the liquid surface. So the portion of this fungi weight will be submerged in the liquid, and some portion will be actually be outside the liquid. So they will just grow on the surface of the liquid. So they will take the nutrients from the liquid through the submerged portion, and it is observed for penicillin production. This surface growth is more productive than the submerged growth. And typically for this production, 25 degrees centigrade is maintained, plus minus 0.5. 25 degrees centigrade temperature is maintained, and in at modern fermenter you get this all control system like pH control, DO control, and also you'll have option to add anti-foaming agent. And in this particular exercise, the vegetable oil, which can be used as anti-foaming agent, also helps in production of penicillin G, because vegetable oil will have different the aromatic compounds, and that aromatic compound can actually work as a precursor to produce penicillin. So when we talk about production in larger scale, again, like any other bioprocesses, first you grow the inoculum. So you have, suppose you are getting the inoculum from a slant, agar slant, then you actually have multiple stages to produce sufficient amount of inoculum. Then you move to the final fermenter. And in modern industry, they use glass line or stainless steel vessel because you are using different acidic systems. So either you use glass line vessel or use stainless steel fermenter, where corrosion of the vessel wall or inner wall will not have, even if you have little harsh environment, to produce this organism. So when we talk about penicillin G production, phenylacetic acid is used as one of the precursor, or you can use phenylacetamide. So it will get sufficient amount of nitrogen source also. So phenylacetic acid or phenylacetamide. And when we are talking about addition of this precursor, you have to make sure that the concentration is not very high, because you don't need their concentration at very high level. It will be around say 0.05 to even 0.1%. Very less. And when you try to measure concentration of antibiotic, we use a different unit. Instead of mentioning it as uh, 20 milligram per liter or 10 milligram per liter, we use a different unit called Oxford unit. So to estimate concentration of antibiotic in the system, we use Oxford unit. Uh, and as per this Oxford unit, generally 0.6 nanogram is equivalent to 1 Oxford unit. So if you are producing antibiotic, then the 0.6 nanogram of antibiotic, like 1 Oxford unit, sorry, on 0.6 microgram of antibiotics is called 1 Oxford unit. So when you try to express concentration, you will express say 30 Oxford unit per ml. That means 30 into 0.6 microgram per ml. That will be the concentration. So for any antibiotic production process, the concentration is expressed in terms of Oxford unit. So even if you try to talk about yield of process, there also you use Oxford unit to say that you are getting certain microgram or certain milligram per ml. Instead of mentioning it microgram milligram, you just mention Oxford unit. And in the same fermentation process, like whatever fermentation process we follow for penicillin production, almost most of the antibiotics are produced in aerobic fermentation. So you need to have aeration, agitation, and also um, glass lined or stainless steel vessel and proper temperature control. So almost all antibiotic process, manufacturing process will have similar kind of phenomena. So similar kind of process step, like from culture to inoculum development, and then finally inoculum development to the final fermentation, and then the downstream operation. So all this process will be very, very similar. So if we just see one particular antibiotic production process, then you can actually get reasonably good idea about other antibiotic production process also. Only difference could be addition of some other precursor or addition of certain additives to get a specific antibiotic. So that additive you can add either during raw material procurement or raw material process system, or sometimes you can just add the raw material directly to the fermenter. So apart from that, you will not have much variation in the upstream and fermentation and subsequent downstream operation. And most of the cases, downstream operations are actually done in different chemical extractor, because ultimately you need to remove a small quantity, like we are talking about production of antibiotic in 20 milligram or 30 milligram per ml concentration. So that small concentration, sorry, not even certain cases you can actually get 1 gram. That means 1 milligram per ml. So in that small concentration, compared to your 4%, when you talk about 4% lactose, you're talking about 40 gram per liter. So in the substrate or in the broth, you have so many other constituents where their concentration is maybe 40 times or maybe 20 times higher. So in such broth, if you need to extract a small amount of component, then separation is quite tricky. So most of the cases, this separation is done through extraction methods. So different extractors are used using different solvent, and then after using multiple extractor and different solvent, you use simple centrifugation to get the solid material. And sometimes we also use some low temperature drying process like vacuum drying, because these molecules are also temperature sensitive. So if you try to do normal drying, then you will not be able to achieve good amount of um, antibiotic, because it is very much possible that during the drying process, because of thermal liability, they're temperature sensitive and thermal labile. So you will actually lose activity of this antibiotic if you use conventional drying process. So for downstream operation or downstream operation, most of the production process will have extraction followed by centrifugation, or the vacuum still or vacuum dryer or crystallizer to get solid antibiotic. And sometimes you also use some sort of filtration device, mostly ceramic filter, which will not interact with the antibiotic. And the ceramic, through the ceramic filter, you can just filter the final slurry, and again you put it to the crystallizer or vacuum dryer to get final dry product. So the downstream operation will be very similar in almost all antibiotic production process, whereas fermentation and upstream will have little bit of difference when you talk about addition of different other uh, raw material or addition of different other substrate. So in the next class, we'll actually discuss about the entire production process of penicillin G, and then also we'll show some synthetic derivatives of penicillin G, and then finally we'll give one more example of antibiotic production, that is either tetracycline or bacitracin. So then you will get a reasonably good idea how to produce antibiotic. Now, two things I want to discuss here. One is the observation we already made during the minor exam. I know online examination is actually not a good examination process because inherently most of the students they have a tendency to copy. So maybe you will score good marks after copying things from notebook or any other resources, but ultimately in long run it will not help you. So maybe you may find it a little bit advisory, or maybe if you think that I'm just giving some simple GAN, but ultimately in long run it will not help you. And while checking the answer book, if we find exact similar match of any descriptive answer, will take really serious action. And those who have actually got caught during copying in this exam, that entire group either has to face disco, or I'll just award them 0 in the minor. And now on, all of them have to actually come to the class regularly. If you don't come to the class, attend the class regularly, don't expect F grade in the final exam. Means don't surprise to get F grade in the final exam. So just be prepared for getting F grade if you are not attentive to the class, if you are not attending the class. And I'm really sorry to say this, the bracket, the student, those who actually relatively newer to the system, they showed a lot of interest that yes, they need to do this course this semester, despite of telling them or actually warning them that they may not have proper prerequisite knowledge, but still they insisted to continue. But unfortunately, in the exam, they took a wrong path. So today onwards, means maybe this word can be spreaded to your friends. Now on, they have to attend all the classes till major exam. So it is absolutely necessary for them to have 100% attendance from now on till major to avoid getting F grade in their final exam. Otherwise, I'll just take everybody to disco, and all the students those are involved in that particular um, yeah, misconduct process, they will all actually get semester F. And when somebody is getting semester F, that semester F will be mentioned in this transcript also. So if you don't want to get to that stage, just try to attend all the classes now on, and also don't say anything about, means don't try to think doing cheating again in the next round. So you are getting liberty, but you don't try to misuse it, because liberty will be given until you misuse. But if you start misusing it, obviously we will not give any liberty to you. And today's class we have discussed about a specific production of antibiotic like penicillin. We'll actually have further discussion of the process in the next class. But then if I teach about tetracycline, that entire class needs to prepare presentation on bacitracin. I'll just name 2-3 other antibiotic. So your homework will be to prepare a presentation and record your voice in the presentation to produce few other antibiotics. So I'll create a submission portal, and also I'll group wise, I'll just prepare a list what kind of assignment they have to follow, like submit. So if I give one particular group to produce a specific antibiotic, other group actually have a different antibiotic, and in that way you will also prepare your presentation, and also you will give a formal presentation. So you will just record your voice on the slide, and then you will just submit the slide to the submission portal. So now on, whatever process I will discuss, you all also need to prepare a similar presentation for other processes of similar bioproduct. Suppose I am talking about acetic acid, which is a um, bioproduct by converting ethanol. Now you have to also give an example of convertible bioproduct and prepare a presentation on that. I was a little bit lenient, but after checking the response of the students in the minor exam, I will actually put a little bit of extra pressure to you. Now on, whatever process I will describe, as a student, you also have home assignment to submit a presentation on the similar kind of process for production of other biomolecules. So if we discuss 6 or 7 biomolecule production process till measure, then the individual student will also prepare presentation for 6 or 7 different individual biomolecule production process. So at least, even if you go for copying or cheating, at least during this presentation preparation, or at least active participation in the group also, you'll put little bit of effort to learn the subject.
So, a few
Anybody?
doubts here. So we'll be preparing a presentation for every topic that you teach. That is every biomolecule that you teach.
No. So if I give an example of penicillin, then definitely you have to prepare for penicillin. Maybe you will be preparing for erythromycin.
Right, sir. So, can we form the groups ourselves and send the sheet to you
No,
guys next
no,
class?
no. I don't buy that statement, because then actually only one particular group will be very, very strong. Other group will not be that strong. So I'll just prepare the group and circulate among the student. And when you talk about individual participation, obviously I'll be able to see how many slides individual students are actually contributing. So suppose a group is submitting a presentation of 30 slides, and 6 members are there in group, then each member will be responsible for preparing at least 5 slides, and also will able to see their voiceover. So 5 slides will be prepared by individual group member, and also they will talk about those 5 slides. So individual contribution will be measured or assessed, and if we find that one particular fellow is actually not contributing much, he or she will actually get relatively less mark while evaluating it. And it
So,
is
but
very
at
much possible
times,
that if we find people are actually cheating or copying during minor and major exam, we'll reduce the weightage in minor and major exam and keep maximum weightage for this assignments. And also we'll go for viva, so at least you will have little bit better assessment.
so one more thing.
Yes.
So at times, like during random formation of groups, sometimes people don't even respond or they don't contribute at all.
No
So
problem, no problem. You can actually see, suppose we are getting, as I mentioned, suppose we are asking everybody to prepare at least 5 slides, right? Now, if you don't get any response from the group member, in your group, whatever presentation you will submit, if one group member is not responding, you will have 25 slides. So you will not lose your mark, because you have already contributed to 5 slides. So you will be assessed based on your performance or your contribution. Not to worry on that.
fine, sir. And so like for the submission, you said that we have to like record the narration as well. So like the person, like a person just has to narrate their own 5 slides, right?
Agreed. Yes. Yes.
Okay, fine, sir.
So, and will you be allotting the topics for the presentation to each group, or do we have to choose the topics ourselves?
Um, Initially, maybe for first few processes, I may give some example, and that will actually help you to choose. And then later, maybe we'll see based on the performance. Means if you can do that, that is the best thing actually. So at least you will also search. Like if I just form 8 groups, so definitely you need to have 8 different biomolecules, which are of similar type of biomolecules, which I've already discussed in the class. Like if I talk about penicillin, then all the 8 group should actually go for production of 8 different antibiotic other than penicillin. So one option is I think it is better to give it to the student that you will create a Google group and you will just choose 8 different biomolecules, and the groups can actually responsible for production, preparing the presentation for individual biomolecules. So now even next class also you'll get relatively good idea about the production process for penicillin. Then you can actually, the class seer can actually circulate a Google spreadsheet, and before circulating it, I'll just form the group. Maybe tonight I'll form the group and circulate among the students. Then group wise, you can just prepare the list of compound you'll be uh, assessing or you'll be studying to prepare the presentation.
Right, sir. And sir, when could we get the marks for the minors?
It will take little longer time because, as I told you, I'll minutely check the similarity between different answer scripts. So it will take little longer time. I think there is a day given in the calendar also. Generally, we get 7 to 8 days after exam. I'll try to finish it as soon as possible. But I was actually not very happy to see the response. If you misuse the trust, then actually it is actually one kind of breach of trust. So I was really disappointed whenever student will not show their integrity, then definitely we have to choose a different kind of path. I'm not here to police you because I don't care whether you are copying or learning, but obviously we do care about your learning process. At least you should learn. So in future, whenever you go for any process development, at least few steps will actually help you to correlate with your current understanding and the future engagement. Anyway, anybody has any other question? Okay, if you don't have any other question, then we'll meet again on Friday, and I'll just share the group details by tonight. And after Friday, you will be actually asked to prepare a presentation on these different biomolecules, and you will get maximum a week time or maybe less than a week time to prepare the presentation. So it will actually create a little bit of pressure, but I can't help on that. I was not intended to do that, but after checking the response in your minor exam, I really felt bad. It is actually not the way to misuse the trust given upon you. Anyway, thank you. Thank you.
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.